Section 8.4 is going to get into rational functions and their graphs. So we're going to take a good look at graphing here. First of all, what's a rational function? A rational function is a rule, or in other words, an equation. Oops, spelled that wrong, sorry. Equation that can be written as a ratio or a fraction of two polynomials. Some examples. 3x over 4x minus 1. That would be a rational function. Or 5 divided by x plus 2. That would be a rational function. Or 6 divided by x plus 5 minus 4. This would be a rational function. Anytime you have a polynomial in the numerator and denominator, it would be rational. And especially when you have the x in the denominator. I'm also going to add that. A rational function, the variable is in the denominator. Good. Let's talk about the parent function of all rational functions. The parent function would be f of x is equal to 1 over x. That's it. That's the parent function. We're going to graph it. So we need to make a t-table. Now I'm going to pick a bunch of numbers for x. Let's go -3, -2, -1, 0, 1, 2, and 3. And you're going to see why I picked all of these. All right, let's plug them in. -3 in for x. That would be -1/3 or -0.3 repeating. If I put -2 in for x, that would be -0.5. If I put -1 in for x, that would be -1. Uh-oh! 0 going in for x. This one is a problem because you cannot divide, if I put a 0 there, you cannot divide by 0. So therefore, this is an error. Doesn't work. Which you're going to see causes a major hiccup in the graph. Well, now let's put 1 in there. I can put 1 in there. 1 divided by 1 is 1. I can put 2 in there. 1 divided by 2 is a half. I can put 3 in there, which will give me 0.3 repeating. All right, so let's go over here to the graph, and let's plot these as good as I can on this smart board. -3, -0.3 repeating would be about right there. -2, -0.5 is going to be about right there. -1, -1 is about right there. 0 is an error. I can't do that one. 1, 1 is about right there. 2.5 is about right there. And 3.3 is going to be out there. Now, people, these graphs are going to be just like your exponential graphs with one exception. It's going to look like something like that. And then here it's going to be, oops, I got to draw this a little better. See if I can on this smart board. It's going to be something like this. That is what a rational function graph looks like. So let's talk about their characteristics. Number 1, the graph is called a hyperbola. This graph is a hyperbola. Now, why is it called a hyperbola? Because it has two distinct pieces that are separated. That need to be graphed accurately. There's the first piece over there, and then here's the second piece right here. There are two curves on the parabola, or on the hyperbola. Number 3, our favorite word, domain. What is the domain? For rational functions, the domain will be all real numbers except the number that causes it to err out. In this case, it errors out when x is 0. So in this case, x cannot be 0. Now, we've learned that word before. That would be called an asymptote. So the line x equals 0 is a vertical asymptote. The range. The range of all rational functions would be all real numbers except y cannot be equal to 0. You notice the graph does not cross the line y equals 0. So the line y equals 0 is a horizontal asymptote. We have two asymptotes on these graphs. And there you go. Those are the characteristics of the parent function and of all rational graphs. Now, let's graph one. We're going to talk about this particular graph. F of x equals 1 over x plus 2 minus 3. Now, this would be a transformed function from the parent function. Now, how do you transform it? Well, this works just like everything else that we have studied so far. The transformed function, and I'm going to do some color coding, would be a divided by parenthesis x minus h in parenthesis, and then the plus k part out here. And it works the same way as always. First of all, a is the stretch or compress. H moves the graph left or right. And K moves the graph up or down. Just like everything else we have studied. All right, so let's answer some questions about this. First of all, the parent function. The parent function of what I wrote in green, get rid of the h and the k, and you have f of x equals 1 over x. That's the parent function. How is it transformed? Well, you notice we have a plus 2 down there, which means my graph is going to go to the left 2. And we also have a plus or a minus 3 in the k spot, which means our graph is going to go down 3. Now I'm going to go back for a second. The graph I have right here, this graph, is going to go left 2 and down 3. All right. Well, good. So let's make a t-table for this graph. X, y. Now, if you use your calculator and type your equation in and go to your table, you're going to notice the error happens at negative 2. That's where the error is. So we're going to leave that as the center. So then I'm going to pick negative 5, negative 4, negative 3. And then on the other side, I'm going to pick negative 1, 0, and 1 because I need the two parts. Well, at negative 5, it's negative 0.33 repeating. At negative 4, it's negative 3.5. And at negative 3, it's negative 4. And negative 1 has a value of negative 2. 0 has a value of negative 2.5. And 1 is negative 2.6 repeating. Okay, good. So let's plot that information. Negative 5, negative 3.3 repeating is, well, it's going to be about right there. Got to erase that little dot there. Negative 4, negative 3.5 is going to be about right there. And negative 3, negative 4 is about right there. Negative 2 is the error. Okay, that's my vertical asymptote. X equals negative 2 is going to be my vertical asymptote because that's where my error occurs. All right, and it also tells me that the H value is the vertical asymptote. So right here, this H value, H will be your vertical asymptote. All right, so let's plot the others. -1, -2 would be right there. 0, -2.5 is right there. And 1, -2.6 is right there. Now, if you also notice, we have a horizontal asymptote right there because the dots are not going to cross that. That's the K value. The horizontal asymptote is the K value, and that will be the line y equals -3. And there we go. So now I can sketch my graph of my rational equation. It's going to look something like that as best I can on the smartboard. Domain. Well, what's the domain going to be? The domain, again, is going to be all real numbers except the x value that I cannot put in there. X cannot be -2. I cannot pick -2 for my domain. The range will be all real numbers except what y value can you not attain? Well, the y value you cannot attain -3. So except y will not be -3. So the H and the K value play very, very important roles. H is going to be the vertical asymptote, and the K value is going to be your horizontal asymptote. I hope that makes sense. If you have further questions, make sure you talk to me in class. But that's how you graph and deal with rational expressions, rational functions, and what they look like when they're transformed.